Hello and welcome to today's Leetcode question. Today we'll be solving plus one. So let's get started. So you are given a large integer represented as an integer array digits, where each digit at I is the ith digit of the integer. The digits are ordered from most significant to least significant in left to right order. The large integer does not contain any leading zeros. Increment the large integer by 1 and return the resulting array of digits. So let me increase fonts. I think this is better. Yeah. So let's look at an example and try to understand this question better. So we have this digits array 1, 2, 3, and the given output for us, the example output is 1, 2, 4. And the explanation is the array represents the integer 1, 2, 3. The incrementing by 1 gives 1, 2, 3 plus 1, resulting in 1, 2, 4. Thus, the result should be 1, 2, 4. And digits 4, 3, 2, 1. And the given output is 4, 3, 2, 2. And the explanation is the array represents the integer 4, 3, 2, 1. And the incrementing by 1 gives us 4, 3, 2, 2, right? And then we are giving this as an output back in the form of an array. So, and let's look in the example 3. I think this is a good example. And if we look in this digits array, we have this number 9, and if we increment it by 1, it gives us 10, right? And the output will be 1, 0. So the initial thing that came to my mind was like, okay, what if I just get the last number in the array by array manipulation in Python, digits at -1, and it's gonna give me the last one and increment by 1. However, we cannot do this because I think we can still work our way around it. I'm not sure, but that's what came to my mind at first. So, and they tell us that um, the large integer represented as an integer array digits, where each digit at I is the ith digit of the integer. So, what do we understand from this problem? We understand that we'll be given digit array, and I assume that all the uh, it's like all gonna be integer numbers. What if are there gonna be negative? So my question is would be to the interviewer, can there be a case when numbers are negative? So like uh, the digits are ordered from most significant to least significant in left to right order. The large integer does not contain any leading zeros. I think that's also very helpful because Mm, we don't want any leading zeros. And increment the large integer by 1 and return the resulting array of digits. Okay, so I assume so they say digits at I. So this each character, let's say, in the digits array will be a positive number between 0 and 9. However, the first one will not be a 0, right? Uh, Meaning, I think what uh, if there's only 0, that might be also the case. Uh, so the tricky part here is what if we have a very, very large numbers? Let's say we have, so understanding part is clear that we have digits array and and we want to increment that integer by 1, right? Which will be in the form of so they say digits lengths can be 100 uh 100 characters long, right? So it's pretty long number. So that's what I understand from this digits increment by one. And let's try to plan our solution. So in this case, how I want to approach this question, right? I could uh, I could basically take each as I go through this digits array, take each character, right, and turn it into a string. Um, and then turn it into a string, and then turn back up to the integer, increment by one, and turn back to the string, and then character by character populate the output array. I feel like this is too much of work. So I think there must be an easier way to solve this question. So let's try to come up with something else. This is something as a backup, but I don't want to rely on this solution. So um, so how can we do? Okay, say we increment. So I feel like I'm gonna go back to the one that I initially thought might work. So, what if we increment the last character in the array by one? So we can increment it as like as as much as like there's no restriction for uh incrementing the last digit, as I am showing the example one. Uh, if it's less than nine, right? If we increment it by one and it turns out to become like 10, let's say, then we might use a carry, right? Like, uh, so it would be like, okay, and we also might uh, take into account the cases when it's like 0, 0, 9, 9, 9, 9, right? So if we just increment by one, we have the carry uh, going up, up, up. So uh, I feel like we need to have this carry thing to be able to increment those numbers if they are say greater than uh not greater than nine. Yeah, that's this is the case when we might end up using a carry. So if I would write a pseudocode, and I'm assuming that there will be since we are told that there will be no negative signs, they're all going to be representative of a positive number. So uh yes. So in this case, let's have some sort of a carry and uh, try to run through some examples and see if that works, right? So what if I have a carry of zero at first, and I'm gonna go from the end of the array and to the beginning. As I go, uh, I increment the last one by one. So increment the last one, let's say loop from back to front, right? We're looping from back to front and increment the last one. Increment the last one. If this results in number greater than nine, right? Say whatever the number was, that number was, we say it was um, like 11 or 12, right? So we need a way to sort of put that number and carry the one that we couldn't fit in that particular uh, index at that. uh, that digits array. So if this results in number greater than 9, uh, carry, use carry, right? And yes, so I think as and in the end, I think in the end, if we have a carry left, what we want to do, we want to uh, add sort of merge two arrays. I think we will have a sort of array with one, with just one. In the end, we'll just check if there's a carry, so we'll do 1 plus whatever the digits array, and we're gonna return. So we're basically putting one in on front if there is a carry, right? So I think I'm good to go, and I'll start writing the code. So let's do it. So carry 0 at first, so and I'll start going from the back for I in range, for integer in range, length of digits, for I in range, length of digits. So I also need a way to handle carry, right? Because I think it might require some thinking before we actually put a carry, check for a carry, right? So for I in range length of digits, what we want to do, and we are iterating backwards, so length of digits minus one, minus one, minus one. For I in range length of digits minus one, minus one, minus one. So going backwards, um, um, and then we want to take the last number. So is going to be equal to digits at I, right? We got the last number. And we want to increment that number. So we only want to increment the last number, right? So I feel like what if we just increment the last one and yeah, we check if I is equal to length of uh, if I is equal to length of uh, digits minus one. So meaning if this is the last index, right? I want to increment. So let's get the number. Num is equal to digits at I. Get the number if it is last number. Uh, increment by one. So we increment by one. So num plus equals one, right? And we just don't want to put that number straight into that particular index because number might be greater the than actually it might be greater than the index. So it might be greater than that. I apologize. So and then we check if num is greater than 9. We want to say if it might be 11, it might be uh 13, it might be 14, 15, right? We want to how do you say that? We just want to and there's an edge case where I also want to put here. uh, check if what if uh, 5 was left as carry, or what if number? Yeah, I mean, what if the carry that we're left with is not 1? So if number is greater than 9, I want to say, okay, take the number, and I think what we can do is say it's 13, right? If it's 13, we just want to put, sorry, how would the math work? So uh, while we have this table or calculation, shouldn't we just say, okay, 5 plus 7 is 12, so we put 2 and we carry on 1, right? Oh, now that makes sense. So I think the way to do it is equal would be if we do, I think it's modular 10. I don't remember the syntax, but that would be like num is equal to num mod. I think if we do this, it's going to get the first digit. Do we want that? No, this is gonna be the carry. We want the modular 10, right? So if we do modular 10, and we also need the carry, so carry is going to be equal to num. I assume that's something like that. So so we're say 8 plus 3 is 8 plus 7. I mean, if the thing, I'm just trying to understand the basic math. So it's going to be, we put 5 and then we carry 1. Yeah. So the number is going to be number modulo 10, while the carry is going to be the number times number uh, integer division. Oh, I'm not sure if it's integer. I think this is some Pythonic thing. I don't remember where I saw that, but yeah. So we got the carry, right? And then we have the number. So what we want to do is we want to say, okay, digits and I is going to be equal to uh, the number, right? And else we just want to say, okay, whatever so I feel like what if this is gonna result, we cannot just add the carry like that. So what if we just do we kind of incorporate that into our calculation. So I only want to increment it by 1. So I'm gonna sort of merge them and I say, okay, uh, I would say number is equal to digits at I, and then I'm not gonna check that if it's the last one, right? I'm only gonna check, okay, I would say I'm only gonna increment it if it's the last one. Yes, that's true. But uh, I think I need to say, okay, plus carry. That's what I'm gonna do here. Yeah, because if we go on with the carry, I don't want to have another if statement for that. I want to capture it in one if statement. So what we are doing here, we're getting the number plus carry, which is going to be 0 at the beginning. And I just say if I is equal to length, which is the last one, incremented by 1, and then check if the number is greater than 9, carry would be number, the first digit in the number. I think this is going to get the first digit, and I think this is going to get the second digit of the number. And then we just put the second digit to the number of the number here, and otherwise we just put the number itself. And after we are done, say we are left with a carry of 5, right? We said, okay, oh, we cannot have a carry of 5, basically. Wait, can we have a carry of 5? No, we can't. There's no way we will have a carry of 5. And I think if there is a carry in the end, if there is a carry, then what I want to do, I say, okay, 1 plus digits, I think result is going to be plus digits. And then I would say, okay, just return digits. I can say result 1 plus digits, otherwise result is equal to. I'm not sure if I need this in another array, but just to be safe, we'll keep it. Return result. So let's go through this one more time. So, oh wait, instead of doing that, let's just put the carry in front, right? Because the carry might be 2. So I would say carry. I should make sure that I'm doing those calculations. So I'm gonna quickly see if there are any breaking changes, and then we are gonna go with we have planned and implemented a solution, right? And then let's evaluate it, let's review it, and then let's evaluate our code. So I have the carry of 0, and then I go for each number in the digits backwards, and I say, okay, number of digits I plus carry, okay. And then I say if it's last number increment by 1, which what I'm doing here is that I get the number plus equals 1. And I say if the number is greater than 9, get the first digit and assign it to carry, right? So carry would be equal to uh, num at the first digit. I think this is how you get it. And then we have the second digit by doing this. And we are assigning digits that I is equal to 9. If it's less than 9, this is not going to execute. And if it's not plus 1, it's not going to execute. And we say, okay. And then at the end, as we have manipulated everything, say, let's try with 9. Uh, just a quick review. So we have this number, and we say, is this the last number? Yes. And we increment it by 1, which becomes 10. And if the number is 9, um, we get the first digit by doing this, which is going to be 1, and we have the number by modular 10th, which is 0, which is the second digit, and we say digits at I is equal to num, and result is equal to digits. However, if carry is there is a carry, I get the carry plus digits, and I return the result. So I think I'll return 10 in this case. Uh, and the bigger complexity of this algorithm, time complexity, let's write it here. So the time complexity of this algorithm would be big O of n. And the reason I say this is because we will only iterate through the whole array once. And yeah, and this is going to be we're going to iterate through each number only once. So, and however, the space complexity is going to be also big O of n, because we are copying the whole thing to another result. If this runs successfully, I'm gonna try to see if there's a way to make it constant. Let's try to run it and see how it goes. Yeah, for now we're good. Let's try to submit it. Here is this number. So we have 899 and then 1900. So we turn to this to 10, 0. This one is going to be another 0, another 0. So I think I'm gonna pull up so 0, 1, 0, 1, 0, 1. However, here it's 8 plus 1, which should give us 9, right? Which should give us 9. And their calculation is correct. However, my calculation. Oh, I already used the so the thing is, I forgot if I don't use the carry, right? If I don't use the carry, say I've already used the carry and I still have the carry, right? So if I have the number, I do this way. Otherwise, I've already used the carry. So otherwise, uh, I think I should just say carry is equal to 0, like for the next time. I'm not sure why it's this color, but let's try running it. So this says you already used the number and setting carry to 0. So run it and let's try to submit. Here we go. Yeah, this was an interesting question. I'm not sure when I've done it. Oh, it's in October, so it's June. And it's been I think a while, and I'm not sure how I solved. Let's look how I solved that question. Oh, I did it. There was this string way, which I personally didn't like it. So that's what probably stick to my mind. But yeah, thank you for joining me today. I'll see you tomorrow with another question, or maybe next time. Bye. Wait, how do you stop this?